Welcome back. This is still Mr. Zabo. This is video 2 of section 3.5 for our Algebra 1 book, and we're going to talk this time about sets and their subsets. If you did not comprehend the first video talking about writing sets in roster form and in set builder notation, please go back and review that video again. Now, sets also have what we call subsets. We know that A is a subset of B if each element of A is also an element of B. So if A is contained within B, we state that it is a subset. For example, B is the set of these numbers, -2, -1, 0, 1, 2, 3. A is the set of these numbers. We know A is a subset of B. Why? Because A includes -1, 0, and 2. All three of the elements in A are inside of B. So therefore A is inside of B, and we state that this is a subset. How we write that relationship? We'll state that capital A, that set here, is a subset. So it looks like a less than or equal to sign, but it's a curve, almost like a C, like contained in the set B. The set of A is contained within the set B, or is included in B. Now we also have another set that we have to talk about. It's called the empty set or the null set. You'll hear me and you'll see that written either way. This set contains exactly 0 elements. There are no elements within the null set. It's another way of saying no solution. And you guys I've seen you write the way that we're going to write the null set or empty set. We write that with like the 0 and the line through it. Or you could write that using the braces, 0 with the line through it, and your brace. So the set that is null, that is empty. Okay. Now let's get some practice with writing sets and subsets. So if I told you that the set P is equal to the letters A and B, that means A and B are the only elements within P. I want us to be able to list every single possible subset. Well, a subset includes the null set. I always start with that. The null set is always a subset of every set. And another subset of every set is the actual set itself. So those are always going to be, every set has at least 2 subsets, the set itself and the null set. Now I'm going to list each other element separately. I have the element A, that's a different subset, and I have the set B, that's a new subset. That's it. There's no other way to split this up. There are 4 subsets to a set that has 2 elements. Part B, my set has 3 elements. So I'm going to have more than 4 subsets. I am still going to start with the empty set or the null set and the set itself. 3, 4, 5. Those 2 sets are the first subsets always. Now I have every possible number by itself. Subset of 3, the subset that represents just 4, the subset that represents just the number 5. That's a subset, just like we had the subset of A and B. But I now, because I have 3 elements, I have other subsets. I can combine any 2 of them. 3 and 4, that's another subset. 3 with 5 is another subset. Now, 4 and 3 is the same set. So the order does not necessarily matter. But I don't want to repeat that. If I wrote 4, 3, that's the same as 3, 4. It's just listing the elements. So standard form is to list our elements of these subsets in numeric order if they're numbers, in alphabetic order if they are letters. That doesn't change the fact that I do have another subset here, 4, 5. Now, 5 is already with 4, 5 is already with 3, so I don't have any other combinations. I have 1, 2, 3, 4, 5, 6, 7, 8 subsets when I have a set that has 3 elements. Okay, last one for this video is our critical thinking question here. It says let the set A equal the set of all x values such that x is less than -3, and the other set B is the set of all x values such that x is less than or equal to 0. Is A a subset of B? I'm going to give you guys, a few seconds here in which I would like you to press pause and think this through and write an answer down and be able and willing to express your reasoning. Write down why. Have you written anything yet? Alright, here's a hint. Graph the inequalities. Hopefully this picture helps. Hopefully we can see that A is definitely a subset, because A is absolutely, completely contained within B. All of A is inside the graph of B. So, yes, A is a subset, so let's make sure that's a curve and not a less than or equal to sign, of B, since every element of A is included in set B. And we will have one more video for this lesson talking about the complement of sets. So go ahead back to Classroom and open up the third video.